The question is to calculate the voltage V1 marked in the diagram and the current I2 marked in the diagram. Okay. Now first of all analyze the circuit. Here the resistor 2K is in series with the resistor 0.2K, but these 10K, 5K and 4K are in parallel to each other. So in a way we can say this 2K is in series with the 0.2K, and that is in series with the parallel combination of 10K parallel to 5K parallel to 4K. So this is what we need to calculate, the total resistance. Okay. And why do we need the total resistance? If you calculate the total resistance, then you can calculate the current I1 coming from the battery. Now this current will come, and you can see that there will be a drop in these two resistors. In 2K and 0.2K there will be a voltage drop. So from 150, if you subtract that voltage drop, you can get the voltage at this point P, and this point Q is at zero potential. So once you do that, you will get the voltage between P and Q, which is same for all the three resistors. And if you want current in any of them, what you have to do is that divide this potential PQ by the respective resistance. That's why we calculate the total resistance first. So let us do that one. Let us calculate the parallel combination first. The parallel combination will give you 1 by 10K plus 1 by 5K plus 1 by 4K as the parallel equivalent, R parallel. Okay, 1 by 10K is 0.1 plus 1 by 5 0.2 plus 1 by 4 0.25. This is 1 by R parallel. So 1 by R parallel is 0.55. It is 0.55. Okay. So what is R parallel? R parallel is 1 by 0.55, which will be equal to, it will be equal to 1.82, approximately 1.82 kilo ohm, 1.82 kilo ohm. So we can see the resistance between P and Q, the parallel combination is 1.82 kilo ohm, and that must be added with the other two because these are in series. So the total resistance will be 2K plus 0.2K plus 1.8K. Approximately 1.8 is sufficient. You can get a rough answer, right? So 1.8 plus 0.2 will be 2 plus 2. This will be approximately 4K. The total resistance of the circuit is now 4K. So the whole circuit can be considered as a battery here, followed by a resistor, and this is 4K, and this is 150 volt. So now you can calculate current I1. It is a current from the cell. So I1 will be 150 divided by 4, which is 37.5. This is kilo ohm, so that must become milliampere. Now this current will flow through this 0.2 kilo ohm. So the voltage V1 will be equal to I1 into 0.2K, which will give you 37.5 milliampere into 0.2 kilo ohm. You can see milliampere is 10 raised to minus 3, K is 10 raised to 3, so that will actually cancel. 10 raised to minus 3 into 10 raised to 3. Now what is remaining is 0.2 into 37.5, and that must be equal to 7.5 volt. So this is a drop across 2 ohm. V1 is 7.5 volt. Now we need to find out the potential at the point P. So that you can see from the diagram that potential at P is nothing but 150 minus drop in 2K and 0.2K. So I'll write like a drop in 2.2K. And how do we get that one? So Vp is equal to 150 minus current is 37.5 milliampere multiplied by 2.2K. Here again milliampere and 2.K. So that will cancel. So this will give you 67.5 volt. So that is the voltage across P and Q, 67.5 volt. Okay, because we know P has a potential of 67.5 and Q is connected to the negative, so which we can take it as 0. So the potential difference between P and Q will be 67.5 volt. Now the current I2, you can see that current I2 is equal to, see the potential at the upper point is, the difference is 67.5 because 4K is effectively connected between P and Q. So I2 can be calculated as V between P and Q divided by 4K, and that is 67.5 divided by 4K. So this will give you 16.875 milliampere. So this is the answer. But see, this is not exact value, near value, because we have assumed the current in the beginning as 1.8 instead of 1.82. So there is a slight difference between the original answer and this answer.